Solve the polynomial equation. To solve a polynomial equation, the best thing to do is to factor it, because if we can get this polynomial equation represented as two binomials, we can set each of those binomials equal to 0 and solve for x. But to factor a polynomial that has an a value greater than 1, the best method is factoring by grouping. So let's start by finding a times c, which is 3 times 3, which will give us 9. And now let's list all the factors of 9, all the numbers that multiply together to give us 9. 1 and 9, and 3 and 3, that's it. And now we need to look at each of these factors and see if adding or subtracting these factors will give us 6, or our b value. This is our b value, the coefficient of our middle term. 1 plus 9 and 1 minus 9 both would not give us 6, so we can't use these. 3 minus 3 would not give us 6, but 3 plus 3 could give us 6. So this is the pair of factors we want to use. Now we rewrite the expression, 3x squared plus, and we add x variables to these, 3x plus 3x plus 3. What we've done is taken our original b value, or rather our original middle term, 6x, and we have split it apart into two terms. This gives our polynomial 4 terms, which allows us to group them into two binomials. And now we can factor. Let's factor out the greatest common factor from each. There is an x present in each of these terms, so we can pull out an x, and we can also pull out a 3. So we're pulling out 3x. What's left over? These 3's will cancel, these x's will cancel, and an x squared divided by x will just leave us with x. Anything divided by itself is 1, so we're left with 3x times x plus 1. Then moving on to the second pair of terms, we can factor out a 3 from both of these numbers. These 3's will cancel, these 3's will cancel. We pulled out a 3, and it's times, it's a positive 3, times x is left over, and anything divided by itself is always 1. So here is our almost our factored polynomial. Now what we do is take the terms that we pulled out of each binomial, and we put them together, 3x plus 3, and then our second binomial is going to be these identical binomials, so x plus 1. And now we have fully factored by grouping. But we're not done. We need to solve the polynomial, so we need to figure out what is the value of x for both of these binomials. So let's start with 3x plus 3 and set that equal to 0. We're starting with this one. Opposite operations, 3 is being added, so let's subtract 3 from both sides. These 3's will cancel, leaving us with 3x equals negative 3. Now 3 is being multiplied to x, so we need to do the opposite and divide both sides by 3. These 3's will cancel, leaving us with x equals negative 3 divided by 3 will give us negative 1. So we know one of our answers has to be negative 1. We can cross out any answer that does not have a negative 1. Now we need to set x plus 1 equal to 0, our other binomial. Here 1 is being added, so the opposite operation would be subtraction. These ones will cancel, leaving us with x equals negative 1. So the only solution is x equals negative 1, making B our correct answer.